Good afternoon, everyone. This is Briscoe from Rezatec. So thank you. What we'll do today is, first of all, I'll give you a very brief overview of Rezatec, of who we are, and then I will introduce Dr. David Smith from Southwest Water, and then he and I will have a discussion about Southwest Water's upstream thinking program and how David and the team have been incorporating Earth observation, data, analytics into the work that they're doing. And then what we'll do is demo the portal that we've built for David, just about 5 minutes, and show you exactly how we've applied different sorts of satellite and other sorts of Earth observation data into a peatland integrity, water quality and decision tool. So you'll see that in practice as well. So just
solution that Rezatec were suggesting, and also we had great concerns that we were missing bits. So we've done the easy hanging fruit on Exmoor, where we know where the restoration is required, and it was making sure that we did an entire job and went back and looked for peatlands we might have missed.
So could you perhaps describe how you've been working with us on looking at Exmoor and then Bodmin, and how we've worked together to
Sure.
use Earth observation for benefit.
Yeah. So alongside the restoration program that we run on Exmoor, we've also been doing a lot of ground measurements and hydrological measurements in a comprehensive, joined-up way that enable us actually to talk a lot about the hydrochemical and ecological properties of those peatlands and the way that they behave. So that data, really, that ground truth data that we already have for Exmoor, we, in a sense, we went to Rezatec and said, look, we have this data, can we work together to develop a product, a peat spotting project, a peat analysis project, using your data and our data to come to a much better quality result that will enable us to use, through Earth observation, map the vegetation, map change in the vegetation post-restoration, and even prior to that to map the damage, those anthropogenic features, particularly the straight line linear features.
And how are the team using the outputs now? We've provided the Exmoor analysis and now the Bodmin Moor analysis, which I know was an area where you had less understanding and exposure to the degradation in the area.
That's right. So we're in a position really where we know Exmoor very well through our own ground experiences, local knowledge. So we use that project very differently from the Bodmin one. Bodmin, we don't have that on the ground knowledge, and we are in the process of basically trying to get a grasp and to map the peatlands, map the damage, and then, as I said, work out the projected cost for the restoration remedies on those peatlands. So by taking that Rezatec data for Bodmin, which has helped to begin to unlock what the vegetation is and what those anthropogenic damage features are across Bodmin Moor, which is an interesting and diverse place, and the peatlands on it again are thin peatlands, they're different peatlands, they're fresh ones in terms of historical development. Some are post-mine working peatlands, for example, so very young peatlands. Huge complexity in the landscape, so we're using that product to help us lay that out in front of us and begin to map and put costs to restoration, and also just to approach individuals to say, look, we now understand you have this kind of peatland on your land, do you want to talk to us about some remedies and those sort of stakeholder activities. So a useful scoping tool, in summary, is how we've been using it. For Exmoor, where we've already done much of that work, it's more about looking to, as I said, to try and understand the bits that we've missed, and getting some knowledge of those, and saving that previous effort that we've put into mapping the ditches from other sources, doing that by the Rezatec portal going forward. Okay,
and what time, just to compare to more traditional methods that you've used to collect this sort of data. I mean, in terms of scalability, you know, what sort of you know, advantages are there, do you think, of using this sort of approach as opposed to perhaps a more ground-intensive approach?
Yeah, and unfortunately, we've not been able to completely replace the ultimate stage of project planning, which is to go out with a GPS unit and log the ditch in the field. But what it does offer is the opportunity for us to load your data onto our GPS units before we go out, and to use that data to help to speed up that field working process and increase the efficiency of that process. So the better data that we have on our mobile units, the better our field work, the more efficient our field work can be. And then it's also just a time within the office, really, in terms of how long we take planning that field visit, you know, where we go to and understanding the need to go. So if we can rule areas out and say there's absolutely no damage here, then that's obviously a time saving. And we don't have that data for Bodmin. That's the thing that we really needed to get some basic data that we could use to do that job. As I say, for Exmoor, we did have that data from our own resources. We flew LiDAR in 2010, for example, and that provided a lot of that linear data as well. But for Bodmin, we haven't acquired that data ourselves, and it was really looking to what was available and the cheapest options for us.
Okay, thank you. And then finally, David, how would you see the sort of application of Earth observation? How would you see this advancing in the future?
Yes, very, very clearly. I mean, I think the advances that we can still make on is working to get better refinement on understanding and mapping the linear features. And in some of the features we map currently as ditches, and then we go out and inspect them still, you know, understanding what they are in advance. But sometimes they are not ditches. There'll be other features in the field. So get better understanding of that. And then ultimately, if it's possible to use Earth observation data for monitoring change, post-restoration, and vegetation change in particular, that will be a great and tremendous step forward for us.
Great. Okay, thank you very much, David. What I'd like to do now is hand over to my colleague Kate William, who's just going to show you the portal for Exmoor that we've just been discussing and developed for David and his team, and just talk you through how we've derived the analysis that we have done using different data layers. So it should give you a bit of an insight into what we've just been discussing. Thanks, Kate.
Good afternoon, everybody. I am Kate William. So I'll take you through the visualization of everything that we just spoke about. So we use Earth observation data and some field data as well, often provided by the client, to look at the soil attributes such as depth and soil moisture, along with vegetation and the anthropogenic features, to assign a composite score for peatland integrity. So if you look on the left side of the screen here, you'll see the various data layers that we use to assign that final score. And I'll start from the end, the final result, which is the Peatland Integrity Index. So what you see there, the orange areas are areas of unfavorable peatland integrity, and the green areas that you see, the dark green areas, are the favorable areas. So what we use to get to that score, we take a look at peat soil depth using, we're able to use field samples of peat soil depth and extrapolate those data points across the entire study area to assess the depth of soil. The deeper areas of soil are the dark blue, and the more shallow areas are the dark red. You can see the legend down in the bottom left gives you the scale that we use there. Some of the other features that we use that were just discussed by David and Philip are the vegetation indicators. So the vegetation that's present that can be an indicator of positive or favorable peatland integrity. I'll turn on a couple of these different layers, but we're able to map this out using optical data, optical satellite imagery. And we're able to classify using the multispectral parts of the imagery to be able to determine what vegetation is present in that area. So we've got about 5 or 6 different vegetation species that we use, provided by working with Southwest Water. We were able to come up with the best indicators. So this was a team effort to look at which were going to be the best positive indicators and which were going to be the best negative indicators to go into that final composite score. Next, we take a look at relative soil moisture. So this is used, we come up with this by using both satellite optical imagery and thermal imagery, where we're able to map out the relative soil moisture where it is more wet and where it is more dry. What we often found was that when we looked at peat soil depth and the relative soil moisture, oftentimes we were able to see that the areas of deeper peat were slightly wetter areas of soil moisture. We also took a look at exposed soil. So looking at where the soil is going to be more prone to be loose, if it's drier soil, if it's more exposed without any vegetation cover, and is more likely to end up as sediments in the water. We also were able to map out the anthropogenic drains. So as David said, those straight line features that have possibly been around for quite some time, but what they like to identify the areas that help with restoration practices. So mapping out the anthropogenic drains, the vegetation, the soil moisture, the exposed soil, peat soil depth, all of these various indicators to get to that final score of the Peatland Integrity Index. We then take it one step further and we look at the flow accumulation of the area using topographic features. We're able to see where sediments might end up to also assign a separate composite score for water quality risk. So what you see here is areas that might have higher risk of lower water quality and lower risk of poor water quality. Zooming into different areas, you start to see where some of the anthropogenic drains might come up as potential indicators of areas that will be higher risk. So I'll try turning that back on and off. Hopefully everybody is able to see those layers turn on and off.
I think that may be a bandwidth issue, actually, why it's not refreshing.
Okay. So hopefully everyone can at least see all of the different layers that we have on the left side that David and Philip talked about during the interview, that I just went over to show how we're able to use Earth observation and field data as well and fuse those various data sources together to come up with a combined score for peatland integrity and for water quality risk as well.
Thank you, Kate. Yeah, I think for some reason the output is a couple of seconds behind your narrative there, but hopefully that's given you a good idea as to the way that we've been applying these different Earth observation kind of sensor data sets, and again, as I said earlier, you know, what we really do, we're really kind of data analysts. You know, we're applying algorithms and different models where appropriate in order to provide really easy to understand visualizations of whatever the problem is we're trying to solve. In this case, it's identify quite a scalable level the state of the peat and its integrity, and then its subsequent effect and risk on the water quality.
So, Philip, can I say a couple of other things to follow on from Kate? She reminded me of. So, on the peatland integrity indicators, one of the things that was listed was northeastern, and we had a specific reason for listing that, which is bog asphodel, because of its association with toxicity in sheep in particular. We wanted to see if we could understand change on a landscape scale of northeastern related to peatland restoration, or even just to understand its current distribution or likelihood of distribution. And then Kate also showed the flow accumulation maps, and they actually produce very similar images to some of the other packages around that are available for mapping flow risk and sediment risk in catchments. And your flow accumulation maps have pulled out some very similar areas, particularly if you notice on the far east side of the peatland mass. Yes, you're about right there. There's an area of moorland there at Codsend that shows it very dark in those flow accumulation mapping. And indeed, it is a high-risk landscape. So West Country Rivers Trust have done a flow risk map of the entire ex-catchment for their project, and they too picked out that area. So there's consistency with this project across to other products that are out there for that application as well.
So as David said, we've been doing this project with David. We've also done projects with working with Scottish Water, and we've done some work with Northern Ireland Water. And in each case, we work with the team to go and validate the outputs in the field. Not only does it validate the methodology, but it also allows us to input and, if necessary, tweak the approach so that we've got ever more accurate analytics. So just to summarise then, the work we've been doing with David and with some of the other water companies I mentioned, we're able now to automate a lot of the processing here, and pretty soon we should be able to look at much larger areas of peatland, looking at things like national maps of peatland extent and measuring the integrity. So if anybody wants to find out a bit more, we're very happy to talk to you about that in a bit more detail. And I know it's a small industry in the UK, so I think you all know each other anyway, so I'm sure David would be happy to talk to you as well. But it just remains then for me to say thank you, David. Thank you very much for taking part today.
No problem.
Thank you to everyone for taking time to join us. And we'll make the recording available as well for people that couldn't make it. Okay, so thank you all, and have a good afternoon. Bye.
Thank you for that. Thank you, everybody.
Bye.
Bye.